Energy Switch is the popular point-counterpoint show where two leading experts with different perspectives discuss the most pressing energy and climate issues in the news today. Next on Energy Switch, all energy impacts the land. We'll dig in with two leading experts.
Funding for Energy Switch was provided in part by the University of Texas at Austin and by EarthX.
We're often focused on the climate impacts of energy, but sometimes overlook its land impacts. All energy systems cover land, but they also use land in the mining and processing of the materials that go into the energy generators, power lines, and pipelines, and use land for their ultimate disposal and recycling. As we seek to understand all environmental impacts of energy and how to reduce them, we'll look deeper at land with Dr. Gurcan Gulen is a principal at G2 Energy Insights, an energy economist working with the Bureau of Economic Geology on a life cycle analysis of energy systems, particularly their land use.
Wind is one that gets really messy. What is the direct impact? Is it simply the footprint of the tower? Because in between, people can do grazing of their animals, they can even do some farming, but then the swept area of the wind turbines when they're turning, that has some impact on the local ecology.
He's joined by Mark Mills. He's a senior fellow at the Manhattan Institute, a faculty fellow at the Engineering School at Northwestern University, a best-selling energy and tech author, and investor.
Yeah, there's a lot of land used by the solar panels, and there's a very good argument to be made that you can get dual use out of the land. You put solar panels on roofs, the buildings, the land's already used. But the tons of material required per unit of energy delivered for solar is higher than any other energy form. Solar uses more aluminum than any other energy form. Aluminum is very energy intensive and very land intensive.
I'm Scott Tinker, and I'm an energy scientist. On this episode of Energy Switch, energy impacts on land. What are the ways that energy impacts land?
So, the simplest, the use of land. If you allocate a piece of land for energy, either an extraction of a resource or building a power plant, building a pipeline, whatever it is, right, you cannot use it for something else. So if you build something on a cropland, fertile land, you cannot grow crops. So there is a cost from an agricultural perspective. But then, of course, there are the environmental impacts. People talk about the biodiversity and ecological impacts. When you build something which is industrial, what impact does it have on the species and flora and fauna in that location?
Sure. All forms of energy impact land.
Of course.
Any additions to that?
We occupy this sort of, call it fragile, but thin, fragile layer of habitable skin on this planet. So when it comes to energy, my operating principle is always and everywhere to minimize the quantity of that precious land we consume to provide essential food and fuel. So the whole direction of society, in my view, morally and economically, should be driven towards land use minimization, footprint reduction.
Well, how do we analyze the impacts of different energies on the land? What are some of the ways we do that?
Right now, we're conducting a research on life cycle analysis. So what it is, you look at the total life cycle of an asset, or the term that is used is cradle to grave. Well, what is the cradle for coal? Well, it's the coal mining. So you have to start from coal mining, processing, and transportation of that coal to the power plant, building and operating of that power plant for 30 to 40 years, whatever it is, all the emissions included. But then, at the end of operational life, useful life, disposal of the equipment and stuff like that. Same applies for wind and solar. You have to mine certain minerals, even for batteries. You have to mine for cobalt, lithium, nickel, graphite. So they have to be processed, they have to be transported, they have to be used in manufacturing the solar panels and so on. And then you build the facility, you operate the facility, and then at the end of life, you dispose of these things. How you dispose of them is also important. So that's the life cycle analysis.
Right. Roughly speaking, just across all the materials, it's about 1,000% increase in materials to deliver the same unit of energy service going wind, solar, batteries versus hydrocarbons, oil, gas, coal. Roughly 1,000% more. So this would be the same as saying, well, I'm going to replace the highways. So I'm going to replace all those highways with a new kind of highway. Happens to use 1,000% more material per mile of highway. The highway will function the same way, but you don't have to be an economist to know it's probably expensive, and you don't have to be an environmentalist to know that probably has a big environmental impact.
Right. Especially when it's wearing out.
Faster.
Faster. Yeah, I don't think we understand that. And the reason for that is something called energy density.
Yeah, that's where...
What is that?
For me, all the life cycle cost analyses are all derivative from the basic principle. The more energy dense the primary energy source you're pursuing, the more likely it is to be cheaper over time and have a lower land footprint, a lower environmental footprint. Imagine you had to move to the next town or village years and years ago, and you had all your savings of $10,000, and you were given two choices in density terms of how to carry your savings with you. You could carry all your savings in the form of pennies or gold coins. The $10,000 is still $10,000, you could argue as an economist to say, but the infrastructure and economic costs associated with moving $10,000 of pennies is a lot higher.
Right.
And that's exactly what's happening with green, so-called green energy. All the number of infrastructure costs, including on the far end, which is waste disposal and recycling, all those costs are bigger by not 10%, but by 1,000%.
Mm-hmm. You see it the same way?
To a certain extent, it is true. But however, if you care about, in the long term, what can you need in terms of energy needs of a modern society, and how can you meet it without, replenishing it? For example, gas-fired generation versus a wind farm. So a gas-fired generation plant can last 40, 50 years, but you have to keep drilling new wells to supply new gas to them because the wells have a certain life. It's an exhaustible resource. Land that you use for wind or solar to generate the same amount of electricity as a gas-fired power plant is going to be much larger in the beginning, but presumably you can use that land forever because we can replenish the solar panels and so on and so forth.
Right.
That replenishment has a cost.
Yep.
That's for sure, on the environment and the economics-wise, right? But then the other way to think about that land use for wind and solar is permanent, even if you're going to keep reusing it. But the wells, if you reclaim the land of the wells, that's not a permanent impact on the land,
right.
If you can reclaim it.
Right. The problem is the replacement cycle of the machinery, which is 2 or 3 times higher, requires mining, which has the same characteristics as the oil and gas extraction. So you end up with this other impermanent, we'll call it exhaustible, not because the atoms disappears, because once you mine them and use them, they functionally disappear from the economy until you, quote, recycle them, and which has another cost. And has so this labyrinth is complex, but I would argue that the outcomes all start from the density of the primary energy source, which is why the holy grail is nuclear fission or fusion one day.
Mm-hmm.
I mean, all energy facilities occupy some land.
That's right.
Just rip through them for me. Just quick, best we can, the land impacts of oil production and use. What are they?
Yeah, I mean, like any extraction, you have to drill wells, and depending on when you are, this is another interesting thing about land impacts. If you're in the deserts of Saudi Arabia, the quality of the land is different than West Texas, than, offshore Venezuela or wherever you are, right? So the location matters in terms of the land impacts. But drilling has an impact. Refining to produce the products that we consume has a land impact. And of course, gas stations and things like that, the delivery mechanisms, they have land impact.
Yeah. How about coal?
Coal mines are big. Not as big as copper mines, but they're big. And you have to move the coal. It's a low-density fuel compared to oil. You have to have disposal for the ash from when you burn it, you produce ash. It has a far bigger footprint than oil or gas because it's a lower energy density fuel.
Right.
It's a far lower footprint than the other stuff we'll talk about.
Mm-hmm. Let's talk natural gas. Pretty similar to oil.
Pretty similar to oil, but natural gas, given its molecular composition, it has less other impacts. Land-wise is the same, but that raises another issue. This is some internal discussion that we're having right now. Like, one of us argued that if it's associated gas that we're using to run our power plant...
Associated with oil.
Associated with oil, right? Mm-hmm. You drill the well primarily because you want to make money from oil and other liquids. Gas just comes along with it. Should you allocate the land impact of that drilling to the natural gas life cycle? One of us argue that no, you shouldn't. Mm-hmm. Others argue that no, you should.
So let me decide for you. Prorate it.
Prorated.
It's not
of course.
complicated.
That's
Come
what.
on. Economists do prorating all the time.
I mean, prorating is the maybe fair solution,
Exactly.
but it's not the rational solution, because what is the rationale for drilling?
Yeah.
Liquids,
Yeah.
not natural gas.
Correct.
Because without the liquids, you would not have a commercial reason to drill that well.
So this is-
Therefore, the land impact should be allocated to oil, not to gas.
I think I know what side you argued. How about solar panels?
Solar panels are just like computers. They have enormous overhead and land use and energy and materials, but you don't see them. They're buried, they're disappeared. Yeah, there's a lot of land used by the solar panels. Everybody knows that. That's the least of it. And there's a very good argument to be made that you can get dual use out of the land. You put solar panels on roofs, the buildings, the land's already used. Should I count that land? Probably not. But the tons of material required per unit of energy delivered for solar is higher than any other energy form. The materials being used upstream somewhere, the land being used to mine, process, the coal being dug up to make the polysilicon. Solar uses more aluminum than any other energy form by a factor, again, of over 1,000%.
Yeah.
It's a big aluminum consumer. Aluminum is very energy intensive and very land intensive.
Right. We know where the oil and gas and coal go when we burn them. The atmosphere is the trash can for CO2 and methane leaks. Where do the solar panels go when they wear out?
Landfill, long and short. They aren't recyclable in any significant way. Maybe someday.
And is it toxic, solar panels?
Yeah, well, gets into the slippery zone. The metals in them are toxic. I'm not in the camp that worries about that, because the metals are locked up in the glass. They're essential to stabilize the glass, not just the solar modules themselves. And the chance that they leak out physical and in the water table are infinitesimally small. I'm just not in the hair on fire camp for that. But what people are worried about is the sheer quantity of landfill. For other things, they should really be worried about wind turbine blades and solar panels, because the quantities of landfill required are truly unprecedented.
Why don't we recycle them? We could, and why don't we?
Yeah, we looked into recycling for our life cycle analysis to decide whether to include it or not, because we need data, the impacts associated with recycling, because recycling itself is not without impacts, right? Somebody has to go to the solar farm, collect the expired panels, transport them to a recycling facility, and that recycling facility is going to have land requirements, energy requirements, and so on and so forth, right? So it's not the end of it. So from a practical perspective, there is not much of it going on, neither for solar or wind. From a theoretical perspective, more of the ingredients of a solar panel can be apparently recycled.
Sure.
But it's not being done much yet because it's not commercially viable at this stage.
So it's cost.
It's cost.
Let me just put a different number into perspective. But usually the recycling is offered as a way to reduce the materials requirement, therefore the future land use. The problem is the magnitude of stuff available for recycling is a trivial share of the magnitude of material we need to build the path that people imagine. By trivial, I mean, even if you had 100% recycling and it were free, you might get 10 or 20% of the materials you need. We have crazy demands for minerals that we're not going to solve with the recycling. That's just a fact.
And people looking down the road 50 years say, but we will then.
Okay, wait till then. Okay?
How about hydro? Oh, he didn't do wind. Sorry.
Yeah,
About
wind is one that gets really messy. What is the direct impact? Is it simply the footprint of the tower? Because in between, there's the maintenance roads and things like that. But then in between, people can do grazing of their animals. They can even do some farming and so on and so forth. But then the swept area of the wind turbines, when they're turning, I mean, that has some impact on the local ecology. So in the literature, people look at the 1 diameter impact zones to 8 diameter impact zones. From an energy density perspective, this is different than environmental footprint, however, right? This is an important distinction. So from a power density perspective, a wind farm is designed optimally, requires all that land, including the space in between the individual wind turbines. But if you can use a lot of the land in between for other activities, from an environmental impact perspective, it's not that large. So you have to deal with these kind of nuances.
But here's a nuance that's missed. For the land use requirement per unit of energy, they just use the same number as for all electric power systems. It's if you produce this many kilowatt hours, you have this many, you just take a pro rata share of the transmission lines. This is a mistake.
That's right.
As you know, because the wind farms are almost always sited further away from where the power is used because you have to go chase where the wind is and build more transmission lines. You should factor in the additional land use given the fact that the resource is further away than optimal and you have to use more land to get the energy to society.
For the power lines.
Yeah.
And you have to mine
materials for those.
materials for those.
A lot of
Good
materials.
old life cycle. How about hydro?
Hydro, depending on if it's the run of the river, is one thing, but that's not usually generating a lot of electricity. If it's a large dam, and depends how you calculate the water coverage, that's the land impact, right? I mean, the most recent that I know is the Chinese moved, thousands of people
1 million.
when they were building the Three Gorges, right? Okay, that's a huge dam, but I mean, in the small dinky town that I live at, there's a water reservoir, and they moved hundreds of people in 1940s to build a dam and a reservoir. So that's a direct impact, environmental impact, social impact. So that's usually the main impact of hydro, how much
And
reservoir.
a lot of cement.
And a lot of cement, the manufacturing of the cement.
Right.
The taller the dam, the higher the generation capability, but the more cement do you need.
Cement is produced with mostly coal and then natural gas and some oil.
Yeah, I think most of us people don't understand that electricity won't make some things.
A lot of coal.
It just takes a lot of heat. You're burning molecules for that.
Yeah.
Correct.
How about the nuclear side on land?
Unequivocally the lowest land use by far. Maybe minimally at least 10x less, possibly in the right kind of designs, 100x less. The path to astonishing reduction in land use, astonishing reduction in environmental impacts is clearly next generation nuclear plants. If there was a game changer that you'd think the two camps, where we'll call it the I don't want carbon dioxide camp and I want cheap energy camp, merging those two camps is really hard. That's the only technology that merges them.
So we've talked about moving energy, land impacts of that. What's the land component of those power lines, pipelines, and moving the energy around?
It's less than a tenth. So if you do in the pantheon of the things you all add up, the land per unit of energy or power, the choice matters. A tenth, roughly.
That sounds about right.
And what's interesting about delivering energy, of course, is that if it's a pipeline or a power line, interestingly have roughly the same energy density. They're very similar, and you can bury the power lines if you want them to be buried. It costs roughly 2 to 3 times more.
Exactly.
But as society gets wealthier, I mean, my operating principle is that if we don't Sovietize our economy, we get wealthier. And in a wealthier future, we choose to spend more money on things like aesthetics, land use, and we'll bury more power lines because we can afford it, not because they're cheaper, which is a good thing.
Certainly aesthetically it's better. Keeping all this stuff in mind, which forms of energy have the lowest impacts and which form have the highest impacts on the land?
If you were doing it simplistically, you go up tenfold each time, roughly.
Okay.
So if you've got an acre to get your service with a nuke, you're going to use 10 acres with oil and gas, you're going to use 100 acres with wind and solar.
Okay.
And if you add batteries, you don't want to use any wind and solar, you add another 10x.
So if land were the only metric, there'd be an easy sorting function.
Yep.
How do we reduce it then? All energies. How do we get the land footprint down?
Okay, I'm going to give you my answer, which you're not going to like. So that demand response in every sense of the word is very important in my mind as an economist to reduce total upfront investment we need to make and the capacity we need to keep operational, and just for electricity system, but an economy, at large, right? So the consumers, we want clean air, clean water. We say we want all of these things, right? But we won't do enough just out of the goodness of our hearts to reduce our energy footprint ourselves.
Right.
So we need to see the price of everything else that we want. If you want clean water, you have to pay for clean water.
Yeah.
We don't pay for water, so we don't know what it costs to clean it and bring it to us. Same thing with clean air and everything else.
Mm-hmm. So you're saying if we put a cost on these things,
If you put a tax on it,
we would
right?
reduce our use somewhat and lower our impacts?
Most people would.
Can data help here?
The big problem with data and information is it's not useful. And if I want to make things easy across the entire supply chain on my choices that have energy impacts, they have to be intuitively easy. Natural language interfaces with artificial intelligence is the hot thing. What that really means is I get to use a supercomputer by talking to it anytime, anywhere, to ask it a question about my behavioral choices. And if it tells me, if you choose to do X instead of Y, you'll probably save this money and do these other beneficial things. And a lot of people will change their behavior.
Right.
Big reductions are possible, but that doesn't change big demands are coming as well. Right. It's just we will moderate them a lot more than we have in the past. And thank goodness.
The rebound effect is real.
Yeah.
We tend to use more when we become more efficient, but we maybe can rebound less. Is that what I hear you're saying, Mark? We can use information and data.
I think the rebound effect, it tampons down the bounce height. So you go from super ball to medicine ball.
So we've been talking about cost benefit and options and trade-offs. Climate is a big discussion globally now. How do you balance climate and land? How would you counsel young people or students of any age to think about that, to balance those two things?
What I would say, different people value these things differently. For, again, 6 billion people, climate change is not a concern at all. They're trying to feed themselves, have a healthy lifestyle, clean water, access to sewage and stuff like that. And you cannot do these things without modern energy. And so you have to allow for everything. So banning investment in new oil and gas development in Africa is unethical and immoral in my view.
Yeah. How about you? How do you balance those two things?
You can't monomaniacally focus on one thing. That's not how the world works. The world works with trade-offs. The three things that governments have always focused on, and engineers who build energy systems of all kind, have always focused on the three metrics: making it cheap, making it reliable, and minimizing the impact. They've always focused on that difficult balance of the three. Mm-hmm. If you choose only one of those, you get bad outcomes in the others, and that's what's happening. That's bad.
It's whack-a-mole, Scott. Whack-a-mole.
It's
whack-a-mole. If you focus
energy
on one thing, you hit that one thing, other problems pop up.
Or the balloon. It's like I imagine when you squeeze a balloon.
That's right. Somewhere else.
That's the economies work.
So we're getting near the end of our time here, which has gone very quickly. But just give you each a chance to sum it up a little bit. How are we going to meet our future energy demands with the least impact on the land?
Wow. I'll pick up where Mark left off. I think the technology is certainly going to be key, right? But there are 8 billion people on this planet. We're talking about a few 100 million people here most of the time. And there's 6 billion people who does not consume modern energy the way we consume.
Right.
And they want to.
Yep, exactly.
So how are we going to get that with least impact? Well, by all of the above, really. It sounds cliche, but all of the above. And cost-benefit analysis is a must. As an economist, I have to, we cannot pick and choose winners early on because we don't know enough. This life cycle analysis we're doing, we're finding out that data is still missing on a lot of these life cycle impacts. We know there are impacts, but quantifying them is a challenge.
Yeah.
We need to understand what people value, where all of these things are going to happen to supply our current modern life in the West, but at the same time bringing them up to a certain, standard of living.
Yeah, we're on the same page. I think if I were distilling it to more of because this is a very political issue, policy matters. Land matters because nothing is more political than land, always has been. It's the measure of our territory, of our wealth, so it matters. There are choices, and the choices vary in cultures and geography. But the choices will include and are including in the world we live in every energy form, including all the hydrocarbons, oil, gas, and coal. So what governments should be doing is making the use of those choices have declining impacts. And it matters to be apolitical, and I mean that in a literal sense, on chasing technologies that reduce footprints. Because you'll get more bang for the buck making internal combustion engines universally 10% more efficient than all the current car subsidies.
That's right.
Why not do that too?
Great visit, great conversation.
Thank you.
Appreciate your candor as always. What I heard from our guests is that calculating the life cycle land impact of energy systems is complicated and involves many variables. Still, Mark's research indicates, and Gurcan largely agreed, that nuclear has by far the smallest impact on land per unit of energy, due largely to its high energy density. Oil and natural gas use more land, coal more than that, hydro, solar, and wind much more than those, and if backed up exclusively by batteries, even more still. This takes into account not only the land used by the systems, but the land and ore for the mining and landfill for disposal, as well as transportation and transmission. The surest way to reduce land impacts of all types of energy is to reduce energy use through demand response and efficiency.
Energy Switch is executive produced by Scott Tinker and produced and directed by Harry Lynch. Sophie Byard is the assistant producer and researcher. Editors are Ginny Patrick, Yusef Swachina, and Jackie Kunzler. Matt Aslanian does the sound. Energy Switch is produced by Arcos Films for the Switch Energy Alliance, with support from the University of Texas at Austin and EarthX.